Okay, so question 8. We have two complex numbers, z and w, and it says find the modulus of zw and find the argument of zw in terms of k. One of the nice properties of complex numbers is when you multiply two complex numbers, you just multiply the multiply the modulus and add the argument. So the modulus of z is 2 and the modulus of w is 8. So the modulus of zw, I can write it as zw like this, modulus of zw is 2 times 8, which is 16. That's just 1 mark, easy. Part B, find the argument. So we just add the arguments. The argument of z, arg z, that's right, is equal to pi over 5. It's this angle, pi over 5. But the argument of w, be very careful here, guys, the argument of w is minus 2k pi over 5, just because of this minus here. So it's cos of minus 2k pi over 5 plus I times sine of minus 2k pi over 5. But minus cos is the same as cos, that's why there's no minus there. And sine of minus is the same as minus sine, why you have the minus there. Anyway, the argument then, argument of zw, all I have to do is add these two arguments. So I have pi over 5 plus minus this, which is just minus 2k pi, 2k pi, let me write that properly, minus 2k pi over 5. Yes, let's simplify this. I can take out the pi, and it's 1 minus 2k pi over 5. If you left it like that, you'd be fine, because it didn't say you had to simplify it. Okay, that's part A and B. Part C. Suppose zw is an integer, an element of z. Find the minimum value of k. Okay, for it to be an integer, so essentially zw, let's write down what it actually is. Zw is now equal to 16 cos of this, because this is the argument, cos of 1 minus 2k pi over 5 plus I times sine of 1 minus 2k pi over 5. That's what zw is. So the minimum value of k, I need to find the minimum value of k such that this whole thing is an integer. Now, if it's an integer, there needs to be no imaginary part. How can I get no imaginary part? Well, I need the sine of this to be 0. How can I get the sine of this to be 0? Well, it has to be this, or the modulus. Well, let's write it 1 minus 2k over 5 times pi. The modulus must be a multiple of pi. And that is because sine, if we want to get this to be 0, sine pi is 0. Sine pi is 0, or sine 2 pi is 0, sine 3 pi is 0, etc. It could also be 0, but k has to be a positive integer, so you're not gonna get a situation where k is 0, because the only way this could be 0 is k would be a half, which isn't allowed. So this has to be multiple of pi, which means 1 minus 2k must be a multiple of 5. And how can I find the smallest value of k such that that is true? 1 minus 2k must be a multiple of 5. That's the only way we can get this to be a multiple of 5. So now we need to basically, so ZW can be negative, but K has to be positive. So just start putting in values of K. This is the easiest way to do this. If you put in K as 1, you get -1. Is that a multiple of 5? No. If you put in 2, you get -3. Is that a multiple of 5? No. If you put in 3, you get -6. Is that a sorry, you get 1 minus 6, which is -5. Is that a multiple of 5? Yes. Therefore, K equals 3. That's the smallest, because it's the minimum. That's the minimum value of K, such that all these things are true. So now, well, that's part I, and then part II. It says for this value of K, find the value of ZW. So ZW then equals 16 cos, so it's 16 cos of, I sub in 3 in here and I get -5, so it's minus pi, cos of minus pi plus I times sine of minus pi. We know this is going to be 0 because sine of negative pi is 0, and we're left with ZW equals 16 times what's cos of minus pi is -1, so ZW is -1 times 16, which is -16.